There's a common question with relativity. People wonder, why can't you go faster than light? And they say, suppose I had a rocket going at 90% of the speed of light, and I shot a rocket off of that rocket going at 80% of the speed of light. Why isn't it going 170% of the speed of light? Well, according to Galileo and Newton, it would, because you just add the two velocities. But what Einstein found is that that's not quite the correct formula. The correct formula is the formula for Galileo and Newton, but then you have to divide by 1 plus the product of their velocities over the speed of light squared. Now, if you're not going anywhere near the speed of light, this is really tiny, and you're basically dividing by 1, which is why Newton didn't notice it. You have to be going close to the speed of light for this to really matter. So what happens when we plug in those numbers? I said that rocket ship A was going at 0.9 c relative to the Earth. So that's the velocity of A relative to Earth. And the B relative to A is 0.8 c. So when I plug in 0.8 c for B relative to A and 0.9 c for A relative to E, and I put them in there as well, I get 1.7 c over 1 plus 0.72. 1.7 over 1.72 is 98.8% of the speed of light. So it still comes out to be under the speed of light. And with some algebra, you can actually prove that so long as your two input velocities are less than the speed of light, this formula will always give you an answer that is also less than the speed of light.